Let's derive a production possibility frontier for a simple economy. Suppose that our economy has 3 acres of land, X, Y, and Z, to use for 2 crops, corn and wheat. This table shows the number of bushels of corn and wheat that each acre can grow. For example, acre Y can grow 100 bushels of corn and no wheat, or no corn and 50 bushels of wheat. We can use this information to determine how much corn and wheat the economy grows for different allocations of its land. If no acres grow corn and all 3 acres grow wheat, we grow 0 bushels of corn, and 120 plus 50 plus 80 equals 250 bushels of wheat. This combination is point A on our graph. If Y grows corn and X and Z grow wheat, we grow 100 bushels of corn, and 120 plus 80 equal 200 bushels of wheat. This combination is point B. If X and Y grow corn and Z grows wheat, we grow 120 plus 100 equals 220 bushels of corn and 80 bushels of wheat. This combination is point C. If all 3 acres grow corn and no acres grow wheat, we grow 120 plus 100 plus 40 equals 260 bushels of corn and 0 bushels of wheat. This combination is point D. When we plot these combinations and connect them with straight lines, we obtain the production possibility frontier in the graph. The economy can reach points inside of the production possibility frontier by allocating its acres differently. If X and Z grow corn and Y grows wheat, we grow 120 plus 40 equals 160 bushels of corn and 50 bushels of wheat. This combination is point E on the graph. Notice that point E has less corn and less wheat than point C. Point E is feasible but inefficient. Why does using acres X and Y for corn and Z for wheat grow more corn and more wheat than using X and Z to grow corn and Y to grow wheat? The answer is that the opportunity cost of growing 1 more bushel of corn using Y is less than the opportunity cost using Z. Y can grow either 50 bushels of wheat or 100 bushels of corn. Therefore, when Y grows corn instead of wheat, we grow 100 bushels of corn, but give up 50 bushels of wheat. 50 bushels of wheat divided by 100 bushels of corn is 1/2 bushel of wheat divided by 1 bushel of corn, or 1/2 bushel of wheat per bushel of corn. As a result, the opportunity cost of growing 1 bushel of corn on Y is 1/2 bushel of wheat. Z can grow either 80 bushels of wheat or 40 bushels of corn. Therefore, when Z grows corn instead of wheat, we grow 40 bushels of corn, but give up 80 bushels of wheat. 80 bushels of wheat divided by 40 bushels of corn equals 2 bushels of wheat divided by 1 bushel of corn, or 2 bushels of wheat per bushel of corn. As a result, the opportunity cost of growing 1 bushel of corn on Z is 2 bushels of wheat. Since the opportunity cost of growing another bushel of corn on Y is lower than the opportunity cost of growing another bushel on Z, we grow less than the maximum combination if Z grows corn while Y grows wheat. By computing the opportunity cost of growing 1 bushel of corn on each acre, we can determine which acre to use first to grow corn, which acre to use second, and which acre to use only after we have used the first 2. The opportunity cost of growing 1 bushel of corn on X is 1 bushel of wheat. X can grow either 120 bushels of wheat or 120 bushels of corn. Therefore, when X grows corn instead of wheat, we grow 120 bushels of corn, but give up 120 bushels of wheat. 120 bushels of wheat divided by 120 bushels of corn equals 1 bushel of wheat divided by 1 bushel of corn, or 1 bushel of wheat per bushel of corn. We've already determined that the opportunity cost of growing 1 bushel of corn on Y is 1/2 bushel of wheat. We've already determined that the opportunity cost of growing 1 bushel of corn on Z is 2 bushels of wheat. Therefore, Y has the lowest opportunity cost of growing 1 bushel of corn, X has the second lowest opportunity cost, and Z has the highest opportunity cost. Since Y has the lowest opportunity cost of growing 1 bushel of corn, it is the first acre to use for corn. That is, if we want to grow corn on 1 acre and wheat on 2 acres, we obtain a maximum combination by growing corn on Y and wheat on X and Z. Since X has the second lowest opportunity cost of growing 1 bushel of corn, it is the second acre to use for corn. That is, if we want to grow corn on 2 acres and wheat on 1 acre, we obtain a maximum combination by growing corn on X and Y and wheat on Z. Since Z has the highest opportunity cost of growing 1 bushel of corn, it is the last acre to use for corn. That is, we want to grow corn on Z only if we plant corn on all 3 acres. When an acre has a high opportunity cost of growing corn, it has a low opportunity cost of growing wheat. This means that Z has the lowest opportunity cost of growing 1 bushel of wheat, X has the second lowest opportunity cost, and Z has the highest opportunity cost. Therefore, Z, the last acre to use for corn, is the first acre to use for wheat. X, the second acre to use for corn, is the second acre to use for wheat. And Y, the first acre to use for corn, is the last acre to use for wheat. The opportunity cost of growing 1 bushel of wheat on X is 1 bushel of corn, because 120 bushels of corn divided by 120 bushels of wheat equals 1 bushel of corn per bushel of wheat. The opportunity cost of growing 1 bushel of wheat on Y is 2 bushels of corn, because 100 bushels of corn divided by 50 bushels of wheat equals 2 bushels of corn per bushel of wheat. The opportunity cost of growing 1 bushel of wheat on Z is 1/2 bushel of corn, because 40 bushels of corn divided by 80 bushels of wheat equals 1/2 bushel of corn per bushel of wheat.